Okay, let's continue on. We're going to do some graphing now. This is a circle. The center is at 0, 0. The radius is equal to 4. Square root of 16 is 4. So I'm going to plot out my points there. And I'm going to just kind of sketch out a circle there. Pretty bad circle, but you get the idea. Let's move on to the next one. Next one is a parabola. We have 1x squared and we have a y term here. So that tells us parabola. Let's put it into kind of our standard form where we have x squared is equal to, I'll keep the 2, is equal to negative y, and then x squared is equal to negative 1/2 y. And this is our standard form. X squared, focus form is what I call it, 4py. In this case, 1/2 is equal to 4p. So I'm not plugging, be careful here, I'm not plugging anything into p. That's not what I'm doing here. I'm doing the reverse now. I'm discovering what the value of p is. I'm going to write an equation that says 4p is equal to negative 1/2. I'm going to solve for p. I want to find out what it is. P is equal to negative 1/8 here. Now, it's an x squared type of parabola. That means it's going to go up and down, up or down. I know that p is equal to negative 1/8, so I know it's going to go down. It's going to start at the origin because this equation here, x squared, it's like x minus 0 squared and y minus 0, so it's right at the origin. It's going to go downward. The focus point is actually at 0, 0 comma negative 1/8. It's actually hard to plot that out. The directrix is at y is equal to 1/8, and that's also kind of hard to plot out since it's so very close to the origin. But I'll just kind of estimate. I'll show it, or I'll draw it out just like that. Let's find a few values of on the parabola, though. I'm going to stick in values like 1. I just use this one. If I plug 1 into my equation here, I get y is equal to negative 2. And if I put negative 1, I get the same thing. So I get this point right here, and so then I can graph that nicely. Make sure you specify the line of symmetry and the focus point as a coordinate. Focus is a coordinate, directrix is a line equation. Y is equal to 1/8. Let's go on here. Next one to graph out, 25. This is a circle. We see the plus sign. We see that the coefficient is 1, 1, and our radius is square root of 9, which is 3. So r is equal to 3. The center of this circle will be at 2, negative 4. So I go to 2, negative 4. I go up by 3, across by 3, and I make my circle with radius of 3. R is equal to 3. And I've already specified the center right there. Number 26. This is an ellipse. Oh no, sorry, not an ellipse. The minus sign says it's a hyperbola. And in fact, because the x squared comes first, it's going to be a left-right type of parabola. Let's figure out how to draw the box. It's centered at 4, 1. We get that from the 4 and the 1 right there. So now we're going to plot out the center. 4, 1 is right there. Um, I call it Rx just to be kind of consistent with the way I name these things with hyperbolas or ellipses. I have think of this as all over 1, so square root of 1 is 1, and then Ry, the square root of 16 is 4. So I'm going to go and make a box by going across by 1 and going up and down by 4. So I draw my box here, draw some diagonals through that, and it goes, as we said, right and left, and so we'll draw from this vertex point on the rectangle that we just created. And now I need to draw my focus points. My focus points, F is equal to the square root of 16 plus 1. Where did I get that from? I have 16 here plus 1 here. Think of it as an invisible 1 underneath the denominator there. So it's going to be square root of 17, which is a little bit greater than 4. Now remember, F is the distance from the center out to the focus point, not from the vertex, from the center. So from the center again is up here at 4, 1. So my focus points are going to be 4 plus and minus square root of 17, 1. So I took my center up here, and then I added and subtracted to the x-coordinate, because it's going to be moving in the right and to the left. So 4 plus square root of 17, 4 minus square root of 17 will be my two focus points, and I can kind of estimate them right here and right 1, 2, 3, 4, right around there approximately. Okay, let's move on. '27. Another parabola. How can I tell? I have one squared term and then a term without that. So I get y squared is equal to negative x when I put it into factor form. In this case, actually, I may think of it as negative 1x. So 4p is equal to negative 1. Solving for p, I get negative 1/4. That's the focus. That's the distance from vertex to focus. Now, this is centered at the origin, my parabola. It's a y squared type of parabola, therefore it goes right or left. So I'm going to draw in my vertex. P is negative 1/4, so my focus is right over here at 0, negative 1/4. My directrix is going to be a line on the other side of that, which is going to be at x is equal to 1/4. And then my parabola, let's actually plot out a couple points, x and y. And in this case, I'm going to plug in a value of y, which is 1. So when I plug in a value of y is equal to 1, I get x is equal to negative 1. I plug in negative 1 for y, I get again negative 1 for x. So let me plot out those 2 points right here and right here, and I get a parabola that goes like that. Again, make sure you call out the directrix as a line equation and the focus as a coordinate. 28. This is an ellipse centered at the origin. So let's draw the center point. Rx is equal to 4. Ry is equal to 7. So I'm going to plot out those points. And I'm going to kind of sketch that around. Now I need to find the focus. F is equal to the square root. In this case, it's going to be 49 minus 16. Remember, it's minus for ellipses, plus for hyperbolas. So this is going to be equal to the square root of 33, which is a little less than 6. So we can actually draw these in right here and right here. And I'll write the coordinate value over here. So it's plus or minus root 33, comma 0 as my 2 focus points there. Okay, getting near the end. Classify each conic section. To do this, we're going to have to use our completing the square things that we learned. Notice the following. I have a y squared. It's already complete. There are no other y terms here, so I don't need to do anything. I don't need to complete the square for y squared, just for the x squared minus 4x. So here we go. X squared minus 4x. And I'm going to add to this plus 4 to complete the square. Plus y squared is equal to 10. And I need to keep my equation balanced, so I add 4 to both sides. So I get x minus 2 quantity squared plus y squared is equal to 14. Divide everything by 14. Or actually, I could just leave it like this. In fact, I will. This is a circle. My circle equation. And the center is at 2, 0. And we could even say the radius is the square root of 14. Okay, next one. We have a negative x squared and a negative 4x. So let's factor out the negative 1. So I'm going to say, factoring out the negative 1, I get x squared plus, be careful here, this negative right there, negative becomes positive right there. So 4x. Oh, let me complete the square while I'm at it. Plus 4. Now let's deal with our y squared term. Plus, I'm going to factor out the 9. Y squared minus 2y. And I'm going to complete the square while I'm at it. Plus 1 is equal to. So I have my 4 here. But now I need to deal with the stuff that I just added in. So I added a negative 4, and I added a 9 times a 1. So let me keep my equation balanced by doing that. Again, let's just review what I did there. I took my negative 4 and added it to the other side. I took my 9 times 1 and I added that to the other side. So I have negative x plus 2 squared plus 9 times y minus 1 squared. All of that's equal to 9. I'm going to divide everything here by 9. And I'm going to rearrange it with some commutative stuff here. So I get y minus 1 quantity squared minus x plus 2 quantity squared over 9 is equal to 1. That's my ellipse equation. Let's get through the next two. Same deal. Need to factor out the negative here. So negative of x squared, and look, it turns into a plus. The minus x right there turned into a plus because I factored out the negative sign. Let's complete the square here. Divide that by 2 and I square it. Look, no y squared term. So I don't have to do anything for the y's. Let's move it all to the other side though. So it's equal to negative 3y plus 24. Now I'm going to complete the square. I get negative of x plus 3 quantity squared is equal to negative 3y. Oh, I forgot something. I added negative 9 to one side. I have to do the same to the other side to keep it balanced. So let's do that. Subtract 9. Why subtract? Because negative 9. So I do the negative 9 on the other side as well. And this is plus 15. Now I'm going to multiply everything by negative 1 just to get rid of the negative. And so I get 3y minus 15. And then I'm going to factor out the 3. So I get x plus 3 squared is equal to 3 times y minus 15. That tells me I have a parabola. It's going to be going up and down. Actually, it's going to be going up because p is equal to 3/4. 3 divided by 4, that's my value of p, 3/4. The vertex, actually, in this case, will be at negative 3, comma 15. Let's write that in. 3, or negative 3, 15 is my vertex. Okay, let's finish off here. Complete the square, x squared plus 20, or x squared minus 2x plus 1, that completes the square. Let's factor out the 25 here. Plus 25, and factoring that out, y squared. I have this negative 150, so I'm going to divide that by 25. That's minus 6y. Let's go ahead and complete the square. Plus 9 equals. I have a negative 201 because I took this 201 and brought it to the other side. So I get negative 201, but I got to keep my equation balanced. I added a 1. And I also added a 25 times a 9. 25 times 9 is equal to 225. So I need to also add 225 here. So then on the right hand side, let's see, what do I have? 226, 201. That's going to be, oh, nice number, 25, perfect square. So I have x plus 1 quantity squared, or x minus 1, sorry, plus 25 times y minus 3 quantity squared. Divide everything by 25, and I am done. So I have x minus 1 quantity squared over 25 plus y minus 3 quantity squared is equal to 1, and that's my solution there. This is going to be a ellipse at 1, 3 as its center point.